What role do the laws of thermodynamics play in heat engines? In recent discussions about energy efficiency and climate change, the role of thermodynamics in heat engines has become increasingly relevant. Many are curious about how these principles apply to the engines that power our vehicles and industries. Understanding this can help us make informed choices as we seek more sustainable energy solutions. Heat engines are devices that convert heat energy into mechanical work. The laws of thermodynamics provide the essential framework for how these engines operate. The first law of thermodynamics is about energy conservation. It states that the total energy in a closed system remains constant. In practical terms, this means that the heat energy supplied to a heat engine is either transformed into work or increases the internal energy of the engine's working substance. When a heat engine absorbs heat from a hot source, it does not convert all of that heat into useful work. Some energy goes into changing the internal state of the working fluid, which is crucial for the engine's operation. This is where the second law of thermodynamics comes into play. This law introduces the concept of entropy, which is a measure of energy dispersion. It tells us that heat naturally flows from hot to cold. No heat engine can be 100% efficient because some heat must be expelled to a cooler reservoir. This is why we see waste heat in engines and why there is always a limit to how much work can be extracted from heat energy. The efficiency of a heat engine is defined by how well it converts heat into work while minimizing waste. Additionally, the Zeroth Law of Thermodynamics is important for heat engines as it establishes a basis for measuring temperature. This law ensures that we can compare temperatures between different systems, which is essential for understanding how heat engines function between two temperature reservoirs. In summary, the laws of thermodynamics are fundamental to the operation of heat engines. They explain how these engines convert heat into work, set limits on efficiency, and describe the energy changes that occur during operation. As we seek to improve energy efficiency in our engines, a solid grasp of these principles is more important than ever.